Greetings, class. This is Mrs. McCoy, and this is page 5 and 6 of our Chapter 8 test review. So, as always, starting with a couple of prompting questions pertaining to in this case, question 10. So, let's see, first thing I want to know is what words represent the x and y for the ordered pair for the problem, what keyword implies the formula we need, and what formula do we actually need. So when we come down, and I would tell you to pause the video and read the problem, and then come back up and see if you can answer those couple of things before I start talking about them. I'm going to pause it so I can reread the video reread the question. Okay, so when I read this question, one of the first things I notice is from the given equation that 3 feet above the ground is represented right here, and the 152 feet per second is represented right here. So what that tells me is that I'm not using either of those two numbers in any of the work that I have to do. So literally, if I wanted to scribble out the two numbers so that I don't think I have to do something with them, we can. Now, they do help us with the units that we have. So that aspect is helpful to us, but the actual implementation comes from the next question. What's the maximum height reached, and how long will it take to get there? So notice I'm asking for both variables. I want to know the time that's in my equation, and I want to know height in terms of time, or the height. So since I'm looking for both things, the only work that we do that gives us both things and is that keyword of the maximum is to find the vertex. So the word maximum is that key phrase that tells me what formula I want to use. And that formula says we can find the two values opposite of b over 2a. And then my function is h. So we're going to take the answer that we get, and we're going to plug it back into our function. Now, the other version of that formula is on the formula page that I'm providing. So if you did prefer that other option, you certainly can do that. Please make sure on the test that you're looking at the formula page and picking out and writing down the formula you have to use. Don't do it totally from memory, because quite often y'all misremember formulas, and the next thing you know, you've totally missed a question because you put in an extra sign or forgot an exponent or whatever. Now, the words that represent our x and y ordered pair, this is really important too. So, and it's part of it's the equation, part of it's the word problem. We see the t squared t, that when we think about our general function standard form, f of x is equal to ax squared plus bx plus c, that x is the variable and f of x is the y value. So knowing that from standard form, the t, which is going to be time, will represent when I get the x value, and h of t, which is the height, will represent when I find the y value. So, of course, ordered pair-wise, we're talking about opposite of b over 2a says find the x, and plug it back into the function. Function name was h, to get the y value. So knowing that, then before we even work the problem down here, knowing that my height is talking about the y value and that my time is talking about the x value, that's how I know which answer goes where. And then, of course, knowing the units that imply height and the units that imply time go with those answers. So coming back to where we need to actually work now, My t-value is found by doing the opposite of b over 2a. So we have the opposite of positive 152 is equal to 2 times negative 16. And we're going to plug that into our handy dandy calculator. Because we're talking about time, we do want to convert that. I believe we get a fraction here. We want to make sure we convert it into a decimal for our next step. So fraction key, 152 over 2 times negative 16. Always check your calculator screen before you move on. And we, oops, I forgot a negative sign. So I was getting a negative time. I know that's not possible. So, which of course then prompted me to go back and look and to go back. And because when my screen opened, it covered my negative sign, I just wasn't thinking about it. But we can see there's that sign I missed. So anyway, that would give me, oh, y'all, anybody see the mistake I made this time? Because I was talking and not reading the screen. Third time's a charm. Is that how that works? So in the denominator before, I'd put times negative 6, not 16. There we go, 19/4. Now, I wouldn't say it's going to take me 19/4 seconds for something to happen. We just don't give answers for time in terms of improper fractions. So that tells me I do want to convert that using my back and forth key to 4.75. And I would leave that as an exact answer. There's not anything in these directions that implies that I need to round or that I want you to round. If I did want you to round to the nearest tenths place, then you would have to keep that answer in this form because we have to plug it in and do more calculations. And then before I reported the final answer, then I would round, but not before. So function notation, my height at 4.75 seconds is going to be negative 16 times 4.75 quantity square plus 152 times 4.75 plus 3. All right, and then again, using our calculator, so I have negative 16. No, see, keep missing that 1 evidently. There we go. 16 times 4.75 square plus 152 times 4.75 plus 3. And that gives us 364. So that maximum height is 364 feet. And that occurred at 4.75 seconds. Now we could take that equation and use the quadratic formula, but it wouldn't give me the highest point. It would give me a place somewhere else within my parabola. And this is a parabola that opens down. So I could ask you to find any answer along the way. I could say, when is it going to be at 350 feet? That's when we use quadratic formula. I could ask you, when is it going to hit the ground, and height being 0. That's going to be quadratic formula. But anytime I ask you for a maximum or a minimum, and well, not even and. If I ask you for a max or min, we know we need vertex formula. Most often, I'm asking you for 2 answers, which is also kind of a dead giveaway that you need this in order to find both values. All right, let's take a look at our graphing. So vertex form of a vertical, a parabola that opens up or down. we know that that vertex form is either f of x or y equal to a times x minus h quantity square plus k. Now, we don't need to memorize. I'm not asking you to demonstrate that form. It just helps us when we have to answer our questions. We know vertex, that if we take that x plus 9 and set it equal to 0, if we want to solve, that the x value is going to be negative. The y value is exactly what's written. And we know that the vertex does have to be in parentheses in order to get its full credit. This is an up-down parabola, and I know it's up-down because of it being x squared. And because this is a positive 2 for my a value, that positive tells me it opens up. Because it's an up-down parabola, my axis of symmetry is going to be that vertical line, x equal to the x value. The absolute value of 2 is 2, and that value is relative to 1. It is greater than 1. And so whenever that value is greater than 1, that's going to make my shape be narrower because my points happen faster. And of course, we remember if it's between 0 and 1, or it's a proper fraction, that makes it wider. And if it equals 1, pardon me, if it equals 1, that makes the shape the same. My y-intercept, in order to find the y-intercept, you have to know that x is 0. So you are going to come in and plug in just the 0. Oh, sorry, that was my mistake. F of 0 and minus 14. My function value at 0 is going to give me, well, let's put it in a calculator. I don't need to do it in my head. 2 parentheses 0 plus 9, close my parenthesis, quantity square, minus, I think it was 17. No, it's 14. Oh, I'm glad I looked. Plus minus 14. That gives me 148. So if the ordered pair 0, 148, that's where this parabola is going to cross the y-axis. That's what y-intercept, of course, means. So we know on a 20 by 20 graph, we are not going to see where it crosses because it's crossing way the heck up there. Now, in order to graph our parabola, we always put our vertex at the center. And because this is an up-down parabola, we know to choose x values. So I'm going to choose the next two values smaller and the next two values bigger. And if I wanted to, I could choose, since I have a little more room on this graph, I could go a little further out because I want to get points, like 1 or 2 more points on the graph, just so that I'm aiming for something. So I could choose like -12 or -13. Let's try -13. Now, we know that these two ordered pair need to match. These two ordered pair need to match. So since I skipped 2 there, whatever I find here will be the same there. So we've picked our values. We know we're picking x because x is the value squared in our equation. And of course, I always like to copy down my equation at the beginning or at the top of my chart, just so that I'm not having to look back and forth too far for the work I want to do. Now, of course, you can just start putting the problem into the calculator. You can write it each time and work it one by one. Ideally, though, what I honestly like to do is come in here and recopy the general form and just leave a blank spot for my x. Because what that does for me is I can look and say, okay, they're all minus 14, they're all plus 9, they all have 2, they all have their square. They all have the same format before I go plug in these values. And then again, I don't need to see any other work from that point. You're just putting that in the calculator, making sure you're putting it in correctly. So 2 parentheses, negative 11 plus 9, close my parenthesis, quantity squared, minus 14. It's going to give me a negative 6. And if we look at the one that it pairs with, inside my parentheses here, I got negative 2. Inside my parentheses here, I get positive 2. Those are the only two differences, so we know that that outcome is going to be the same. Okay, 2 parentheses, negative 10 plus 9. Close parenthesis, quantity square, minus 14. Whoops, I did minus 1. Doggone it. I never did figure out how to go back in and change. I'm just going to have to retype it. 2 parentheses, negative 10 plus 9, close my parenthesis, quantity square, minus 14. All right, that looks good. It's going to give me a negative 12. And inside this parenthesis gave me negative 1. Inside this one gives me positive 1. I know those are going to match. And then that bonus one that I did, and I could have started there. And that was going to give me positive 18. And then this one would be positive 18. So let's take a look at this graph. And that's that last bit of doing your work. So negative 9 and then down 14. Now, if you look at that, you can see that I put it in the wrong place. I put it under the 8 instead of under the 9. Very common. That's one of those things. That's why it's one of those things I always check. Okay, next, negative 10. So 8, 9, 10. And then down 12. Now notice I didn't count there. I just looked at 2 above, and also the 12 happens to be marked, so I can follow it. And then negative 8, negative 12. Now see my symmetry to my points. If I'm plotting symmetric points and I'm not getting symmetry, then most likely something's wrong with how I'm plotting my ordered pair. All right, negative 11 and 6. 1, 2, 3, 4, 5, 6. And negative 7 down 6. And we can graph our parabola from right there, but we really want a little bit more so we know what we're aiming for. And my screen just timed out, telling me I need to plug the power back in. There we go. So, and that's why I did those extra points. I can just do the 5. That's all I require. I just want to be careful because when I do this extra, 13 and then up 8, 1, 2, 3, 4, 6, 7, 8. And then over -5 up 8. That just gives me something that I'm aiming for, and we know that this needs to be a curve. And so as I'm coming up, notice we're gently going out. When I hit that last point, I need an arrow that we start curving right away. Hit that last point, we're still going outward. I need an arrow. So that's what my graph should look like. Pardon me. If I did ask you to graph the axis of symmetry, we know that that's the vertical line that goes through our vertex. It's always a broken line. And when I look at that, if I were to fold my graph in half, those two sides should match. So if they're not matching, I've either done some math wrong or I've plotted the point just a little bit off. So take the time to look for that. Okay, next. Graphing our circle. And when we're graphing our circle, we do notice that we have the two sets of parentheses. So that means both of these can be set equal to 0, both expressions, to get those values for the center. So I see the center of my circle is at -3, +4. Radius, we know we can write 6 as a quantity square because they each have to be a quantity square to read the information. So that root number is the 6. Start with my center, -3, +1, 2, 3, 4. And then from my center, we're going to count up 6, 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, and over. Now, when you visually inspect that, if they don't look lined up the same distance, if that visually doesn't look right to you, recount. And because it's a circle, then we're just drawing that curve as we go. I always have trouble with that bottom point hitting it. That more or less looks like a circle. And so the biggest thing the biggest amount of points for this one is going to be that you got the center in the right place, and then next, of course, that you have the radius, and then graphing it. I might choose to make the graphing multiple choice where you pick out the correct one, so it will be a matter of you having picked the correct ordered pair. So if that's the case, do make sure you very closely read those, because I'm going to have all kind of combinations of choices if I do that. I may not have time. All right, and then our last one. So this time we see that our y is square. So we know that this is going to open left or right. Because this is a +3, positive tells me that it opens to the right. The 3 tells me my shape gets narrower. And let's see, vertex. Outside is my x, inside. Let's see, yeah. So we're going to go over -7, up 5. 1, 2, 3, 4, 5. There's my vertex. And we said it was going to open to the right. So that's what our graph better look like. If it doesn't, then you were treating it like it was an x square, not a y square when you did it. And again, because the y is being squared, I'm going to pick my y's. And of course, we always put our vertex at the center because we're picking y's too smaller to larger. I like to have my equation right above. And I like to set up before I plug in. Somehow my handwriting is, or I'm starting it further and further over, so I'm squeezing it in. Try that one more time at the beginning. All right, that's a little better. And then, of course, fill in your values. 3, 4, 5 was my center, 6, 7. And let's go to our calculator. 3 times, parentheses, 3 minus 5, close my parenthesis, quantity square, minus 7. Whoops. Oh, didn't do minus, I did subtract. Or I didn't do subtraction, I did a negative sign. There we go. So that one should give me a 5. Next one, 3 parenthesis, 4 minus 5, close parenthesis, quantity square, minus 7, gives me a negative 4. And so inside my parenthesis, I have 4 minus 5, which is negative 1. In my matching set, I have 6 minus 5, which is positive 1. So we should get a matching value once we square. And we got negative 4. So because this is a left-right parabola, I'm going to have x values that are matching. So that means those two have to match. As long as we've checked at least one of our pair, we're fairly confident. And I always like to look again what's inside the parentheses. 3 minus 5 is negative 2. 7 minus 5 is positive 2. My next step is to square. And so both of those, when I square them, turn them into positive values. So as long as I got the first answer correct, then it's going to match to that one. And I think for whatever reason with left-right parabolas, doing my vertex in one color and the rest in another, sometimes it's just helpful. So over negative 4 and up, 1, 2, 3, 4, and up 5, 6. So there's a pair of symmetric points. Then positive 5 and up 3, 1, 2, 3, 4, 5, 6, 7. And again, this was a very narrow parabola. But it's still going outward in both directions, still has an arrow in both directions. All right. And then what kind of question might I give for a bonus? If you think of something you think would be a good bonus question, then email me. I haven't decided what the bonus is or if I'm even putting a bonus on, so there's still time for you to influence my decision. Okay, hope this graphing review helps, and good luck on your test.